All right, I don't have a template to go along with this because it's just too easy to go ahead and draw everything out on your own. But we're going to be talking about transformations, and there's three main types we're going to be talking about today: a translation, a reflection, and a rotation. Okay, this comes out of lesson 4.8 in your textbook, and the title of it is to perform congruence transformations. Congruence transformations. Okay, and now to go back to the definition of the word congruent. Congruent means same size, same shape. So basically, to do a congruent transformation, we're going to start out with an image and it's going to stay the same size and stay the same shape. That's not going to change. Okay, then to define transformation. Transformation is the shift or movement. The shift or movement of a figure. Now, whenever we're dealing with this on a coordinate plane, you're just counting. You're counting units of measure, and that's it. So you'll have your x coordinate and your y coordinates, and you'll just be counting and moving the figure along. And we're going to practice on one in just a second. All right, now then, you're going to be seeing some things referred to as an image and a pre-image. All right, so if you see the word an image, okay, this is going to be the new figure. The new figure created from the transformation. As you might be asked, what are the coordinates of the image once it's been translated? And that would be the one that was just created. If you see the word pre-image, all right, this is the original figure. So it's the one you started with. It was in that particular spot. All right, I'm going to draw a little diagram called transformations. All right, and from here we're going to branch off into the three different types of transformations I was talking about. The first one being a translation. The second one being a reflection. And the third one being a rotation. Okay, so to define a translation, this is to slide or move a figure. All points move the same direction. All points move the same direction. Okay, to draw a picture of what that means. Get this boxed in here. All right, if I were to draw, let's see, get a little line right here. And I have this figure. Just going to draw a funny shaped figure right here. And if I were to translate this figure to a new position, what I would do is I would take each one of these points here, 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 and here, and move them all the same direction, the same number of spaces. So let's just keep it simple. Let's just say I'm going to slide everything 5 spaces to the right. And if I was on a coordinate plane and I went 1, 2, 3, 4, 5, this would be my new point for here. And this would be right here. This one be right down here. This one would be right over here. And this top one would be right up here. so that when I connected my points, I would have the same size, the same shape. Okay, now we can move it left or right or up and down, but all of the points move the same direction, the same number of units. All right, the next one, reflection. A reflection is a mirror image across a line, and we call this line line of reflection. Now, there can be many different types of lines of reflection. If you had a coordinate plane, the x-axis could be a line of reflection. The y-axis could be a line of reflection. You could even draw y equals x, and this is a graph of y equals x, and we can reflect across this. You could have a horizontal line, y equals 3, and then you'd have this line right here where y equals 3. And this could be your line of reflection. There are so many different ways to do this that you have to be real careful and pay attention to which line they're wanting you to reflect across. This is the line x equals -3. We can reflect across it going left to right. So many different ways to reflect across a line, but to practice, I want to do a little line here, and I'm going to draw the same image as best as I can. Okay, and I'm going to reflect it across this horizontal line. Now, one thing that I like to do when it's a reflection is just count how far I am to that line, because every point's going to be the same distance but on the opposite side. So this point right here, if it was 1 unit, it would be 1 unit this way. Here, 1 unit to the line, 1 unit across. This point, let's go 1, 2, 1, 2. And this one, we could go 1, 2, 3, 1, 2, 3. And this one, we could go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And then we just connect these points. And then it's just a direct reflection across that line. So we reflected it down this way. We can also refer to that as a flip, to flip it. Okay, I'm going to draw a little box around this. All right, now then, a rotation. A rotation is such that it turns a figure about a fixed point. About a fixed point, called the center of rotation. Okay, so we've got our 3 different examples right now of a transformation. To draw a picture of this particular one, what I'm going to do for rotation is I'm going to create a particular point right here. We're going to call this point P. Okay? And I'm going to take this same figure that I originally started with, okay, and I'm going to rotate it approximately 90 degrees. Okay, we'll be dealing with this a little bit more when we cover Chapter 9, but just to give you an idea of what each one of these would look like as an after effect, these are exact mirror image. This one is turning around a point, and this one is just kind of sliding across, up or down. All right, so those are the 3 types of transformations. Now, in Chapter 9, I want to go ahead and discuss Lesson 9.1, because this could be on your EOC, your STAR test. I'm going to zoom in just a little bit. I feel like this isn't a very clear picture and it's bothering me. Let's see. Is that better? Nope. There we go. Okay. And this one is called Translating Figures and Using Vectors. Translate figures using vectors. Now, you've not seen vectors before. That is the one thing that's going to be new in this particular lesson. Okay. This is something that you're going to be touching upon a lot more in pre-cal. We just recently started putting it into the geometry curriculum because of STAR testing. Okay, this all has to do with translating in a coordinate plane. Okay, translating in a coordinate plane. All right, what we're going to do is we're going to start off with a quadrilateral. We want to graph quadrilateral A, B, C, D with points A being at -1, 2, B is located at -1, 5, C is located at 4, 6, and D is located at 4, 2. Now, I've got a graph that I'm going to use just so that you can see it visually, and if you need to draw a graph or if you have graph paper, you can go ahead and grab some out right now and use it. But don't worry about it if you don't. It's not anything major. And I'm going to graph these points. A at -1, 2. B is at -1, 5. C is at 4, 6. And D is at 4, 2. Okay, and if I were to connect those points, I would have a quadrilateral that was a trapezoid. All right, now, if I'm going to translate this image, okay, translate the image, and we start off, and what we do is we put X, Y, meaning if whatever the original points are, we're going to add 3 to the X coordinate, oops, I wasn't supposed to do that, comma, and subtract 1 from the Y coordinate. Please excuse that, that's not supposed to be there. Ugh, that's why I don't like pens, because you can't erase. All right, so now then, I'm starting out at A, -1, 2. Now, if I'm going to add 3 to my X coordinate and take away 1 from my Y coordinate, my new point is going to be A prime. 3 to this would be located at 2, and taking away 1 from this coordinate would be 1. So my new point would be located at 2, 1. Point B started out at -1, 5. If I add 3 and take away 1, I'm going to be at B prime, 2, 4. If C was located at 4, 6, C prime is going to be located at 7, 5. Add 3, take away 1. And point D is located at 4, 2. So D prime is going to be located at 7, 1. Okay, now this little marking here represents, it stands for prime. So I want you to make a little note that A with that little marking, it's not an exponent, it means A prime. And that is your new image. Okay? If there's two little markings, that's a double prime or triple prime, because you can reflect an image and reflect the reflected image and reflect the reflected image if you wanted to. So you just kind of keep going on, adding a little mark for each time you've had a translation there. Okay, or a transformation, I should say. Now then, what I want to do is I want to graph my my new image, A, B, C, and D prime. So my new one would be at 2, 1. That's A prime. At 2, 4. That's B prime. At 7, 5. That's C prime. Oh, oops, that's not 7, 5. That's 5. Yeah, it is. Oh, I'm okay. Woohoo, woohoo. That's C prime right there. We're good, we're good. And then D prime is at 7, 1. Right there. So now I connect my dots, and I have a transformation that was nothing more than a translation that I slid or glided to the right and then down. And I put the little prime markings to show that that is my new image that was created. All right, now to go on to a couple more words that you need to know, some definitions. If you ever see this word isometry, or you might hear it as an isometric translation. Basically what that is, it's a transformation that preserves length and angle measure. It's a congruence transformation. Okay? So it's just a fancy word for let's transform this sucker. Let's move it. Let's reflect it. Let's do something with it. Okay, the translation theorem. Yeah, this is stupid. I don't even know why I'm going over this. The translation theorem is simply that a translation is an isometry, simply because it's a congruent transformation. It doesn't change size, it doesn't change shape. It just slides and glides. It moves right on over. Okay, now we're getting into some new stuff. A vector. Let's talk about vectors, shall we? A vector is another way to describe a translation. Okay? It has both direction and magnitude. Magnitude means size. Okay? All right, so now then, this is referred to by an arrow from one point to another. Okay. I'm going to get another color here and give you example. If you were to see FG with only a half arrow there, it doesn't go down below, it only goes on top. That would reads as vector FG. You know, we've had ray, line segment, all these different little markings on top. This one represents vector. Okay? Now, I'm going to draw a picture, but I want to flip this over because I'm going to need a little bit more room than what I left myself there. So I'm going to flip this over on the back side here and draw this out. I'm going to start with my initial point, F. Okay, F is my initial point. Or you might want to use the word starting point. Okay, that's where you begin. Okay, G whiz, is going to be my terminal point. Or you might want to refer to it as the ending point. Terminal or ending point. Okay, my vector runs from F to G, but how we describe it, okay, we describe it giving it direction. All right, to get from F to G, I'm going to say, pretend like I have to move 5 units to the right. If this was on a coordinate plane. And then I have to go up 3 units. Both of those being positive directions. And now this is our horizontal component. Horizontal component, telling us which way we're moving, left or right. And this is our vertical component, saying are we moving up or down. Okay, now this is just like if you were on a coordinate plane. If you're moving to the right, that's a positive direction. If you're moving to the left, that's a negative direction. If you're moving up, that's a positive direction. And if you're moving down, that's a negative direction. So since we moved right, our horizontal component's going to be positive. And since we moved up, our vertical component's also going to be positive. So we would write this, if you were asked to write this in component form, it combines the horizontal and vertical components. Okay, so to combine the horizontal, how about horizontal and vertical? But horizontal is if you want to combine those two words together. Horizontal, just developed by Miss Battles. Okay, the component form of vector FG is 5, 3. 5 because we moved horizontally a positive 5 units, and 3 because we moved vertically a positive 3 units. If we had moved to the left, this number would be negative. And if we had moved down, this number would be negative. Okay, so this does not mean that's where it's located. This means the direction we moved to to go from one point to another. Okay, so be sure you understand that this is a direction, not a location, when you have a vector written in component form. Okay guys, that is it for right now. This is all you need really to kind of get you going for the STAR test, and we will be covering the rest of this Chapter 9 stuff after May 14th. Thanks.